Alright, so we have an interesting question under application of differential calculus. So let's try to think a bit here and see how we can handle this question. So we are told the farmer plans to fence a rectangular pasture adjacent to a river. The pasture must contain 405,000 square meters in order to provide enough grass for the herd. No fencing is needed along the river. What dimensions require the least amount of fencing? So I just had to draw something here to just try to picture what's going on here. So look at this. So in my view, if we're going to have a least amount of fencing, we'll assume the river is along the longer side, in that we can have something that can instead come out like this. Yeah, and of course we assume the river is like us straight, just to make things easy for us, since we're trying to think of a rectangular shape formed. So if we look at what I've come up with so far here, if we call the shorter sides to be the breadth and then the longer side to be the length, our perimeter is going to be, we're going to have two shorter sides and then plus one longer side, since the other side has been covered by the river, so we won't have to show the other length. But of course we know that the area still stands and depends on two sides, the product of the length and the breadth. So these are the two equations we have, and that the ones we can use. What information do we have? So we've been told we need to have an area of that much. So the area is 405,000. Okay, and then we have got our LB there. So now from this formula we can try to make one of them to be a subject. I can make let me make the length to be a subject. So if we try to make L the subject, we are going to divide by B and B. So L becomes 405,000 over B, and then we can substitute in the other equation. So we have P is equal to 2B, and then for our length we've said it's 405,000 over B. So the way we tend to attempt these questions is, you basically, whenever you come up with equations, what you're supposed to do is try to manipulate the equation where you have a given number and then make any of the letters a subject and then try to substitute in the other given equation. Yeah. So at this point we've now come up with an equation which is having a single variable B on the right hand side. So at this point we are now at rebut over just trying to differentiate this equation. That's now where the calculus comes in. So we have P is equal to 2B, and then I can just take the B on top. Whenever you take something, a variable on the numerator on top, it is raised to a negative power. So if it was B squared, it was going to be B to the power minus 2, but in this case it's just a 1, so it's negative 1. So dP, differentiating P in respect to B, is going to be the derivative of 2B. You know, whenever differentiating, you remain with a constant if you've got a power of 1. So that gives us a 2. Then the derivative of 405,000 b to the power negative 1, it becomes negative 405,000. And then the power there, you know, you subtract by 1, it becomes the power negative 2. So you can gladly take the b minus 2 to the bottom so that it becomes a positive power, which is just a b squared. Okay, these equations can be removed. We can leave the one where we have L the subject, because we need to have to find that. So now at this point, this is where now the calculus comes in. So basically what happens here is calculus helps us to find the maxima of the minima. Okay, so the x values, we understand they are the critical points at that point. So, and that occurs at the point where the derivative is equal to 0. So therefore, for us to find the critical points, in this case we can equate the derivative to be equal to 0, And then don't forget we have a 2 minus 405,000, and then we've got over b squared there. At this point we have to take this one the other side. Of course, we had the additive inverse on both sides, so that on the left hand side you have a 405,000 and then over b squared equal to a 2. Close and multiply, the b squared appears on the other side, it becomes 2b squared. Divide by 2 both sides, or multiply by half in other terms. That's what we're trying to do. When you divide by 2 there, you have 202, okay, 500 equal to b squared. You know, whenever we've got a square, you can find the square root both sides, and of course in such cases we're dealing with dimensions, we're interested in the positive value alone. So the square root of 202 500 is just a 450. So that's our dimension. So 450 meters. You can easily find the L by plugging in there. L becomes 405,000 divided by 450. So L becomes 900 meters. So if we go back to the question we had, of course taking the assumption that our river is along the longer side, what we're trying to say is we have 450 long breadth, and then just our length is like 900. So basically this is what we have pictured to give us the best dimensions that would require the least amount of fencing, in my view. Okay, so that's it for this video. I hope you've understood how to apply differential calculus in answering questions that require the minima or maxima values.